investment where compounding is done more than once a year. So as per formula, so this is the formula for the effective rate of interest, where RE is the effective rate of interest, R is the normal rate of interest. So I'm writing this as ROI, and M is the number of times compounding is done in a year. So if compounding is done twice a year, that is, it is a case of semi-annual interest, then M will be 2. You divide the rate of interest by 2 and multiply the time period, that is the year, into 2. So 2 would be the number of times compounding is done. Now this is the effective rate of interest which is calculated annually. Annual equivalent of the interest which we are receiving when compounding is done multiple times a year. So let's take a simple example, and you will be able to calculate the effective rate of interest. Say an investor has two options. He wants to deposit 10,000 rupees in bank for 1 year, and the bank gives him two choices. One choice is that he can invest 12 the amount at 12% per annum compounded monthly, or the second option is receive 12.25% compounded half yearly. So you need to tell the person which of these two options is better for him, to go for option 1, which is compounding monthly of 12%, or option 2, 12% compounded half yearly. So how do we solve this question? Yes, someone has solved. Yes, wants to answer. There was a doubt. Okay, so I'll continue then. So in this case, when 12% is compounded monthly, how do we calculate the effective rate of interest? 1 plus RE, and this will be raised to the power 12. This will be the effective rate of interest for the first option. See how much is the return coming to. For the second option, okay. So you have Tanmay given me the amount he'll be getting after 1 year. So yes, this rate of interest will come out to be 12.68%. Amount received will be rupees 11,268. So you can calculate, if you are asked in the question that what will be the effective rate of return, it is 12.68%. Similarly, for second part, the effective rate of interest and amount is what we need to calculate. Yes, Tanvi?
Ma'am, for half yearly, we have to divide it by 2, right?
Yeah, okay, I have taken it quarterly. Yes. 2 and into 2. Yes. So please tell me what is the effective rate coming to in this option. This past. So this is coming to 12.62%, which you see is lower than the first option. This means that approximately the return, the amount at the end of the year will be 11,262. So in this case, option 1 is giving us a better return and hence it should be preferred. So if 12% is compounded monthly, then your annual return is coming to 12.68%. That is what effective rate of interest means. Okay, I hope all of you have got this answer. We'll move to the next question. Okay, so in this question, Mr. X has to make a deposit of 1 lakh in a bank for 1 year, and there are 5 banks which have given 5 options, and he needs to calculate which of the options is best. Obviously, the option that gives the highest effective rate of interest would be preferred. Now, in this case, you have weekly, quarterly, yearly, monthly, half yearly compounding. You can, for the time being, leave part A because that would be 52. तो वो log से solve करना पड़ेगा. I will give you the answer for bank A. Rest you can solve. बैंक B का effective कितना आ रहा है? C, D and E. Start solving. I'll ask you people to share the answers. For bank A, I'll share in a minute. Start solving. You need to calculate the effective rate of interest. I'm writing the formula again here. Very good. Only one student is solving. What happened? What about others? Bank B, the answer is 10.47%. And after that, what is the answer for bank C? Anyone who has solved can give the answer in the chat box. Yes, so I should start asking individually then. No one is answering here. Yes, Tanvi, what is the answer for bank C? Okay, good. I have one answer for bank C, 10.48%.
I'm still calculating. Just a minute.
Fast, fast. Don't take so much time. 10.48 is correct for bank C. Then bank D. So bank D, it is coming out to be 10.46% at monthly compounding. And bank E is a direct class. It is already given annual compounding. So 10.3 is the effective rate of interest. So the effective rate of interest or the annual rate of interest under all these options is given to you on the screens, and we can clearly see that it is bank C which will give the maximum return on the investment of 1 year. So this should be preferred out of the available 5 options. So the more the number of times compounding is done, higher is the effective rate of interest. Now here there was some variation in the interest rates, but say if you start with 12%, तो 12% जितनी बारी compound होगा उतनी बारी उतना ज़्यादा आपको return मिलेगा in annual terms. Okay, so this is what we mean by effective rate of interest. We move to the next question. So now we solve a question on perpetuity. What is perpetuity? Has anyone heard about perpetuity? So perpetuity is nothing but an annuity that continues forever. So generally in questions you're given that annuity of 5 years, of 6 years, but if there's no time limit to the annuity, then it is perpetuity, and present value of perpetuity is the annual cash flow divided by the rate of interest. So there's a direct formula here to calculate the present value of perpetuity. annual cash flow divided by the rate of interest. So, how perpetuity is used practically, generally जो scholarships based schemes होती हैं वहाँ पर a lump sum deposit is made, and then that deposit gives some return annually forever. So a similar question here is given to you, that a businessman institutes a scholarship of 10,000 per annum for an outstanding academic performance in some educational institution. He wants to know the sum of money he has to invest at 10% so that it yields 10,000 per annum in perpetuity. So, one lump sum deposit which leads to a scholarship of 10,000 rupees annually forever. So, direct your annual cash flow required is 10,000. The rate of interest is 0.10. So you get the perpetuity, the present amount that needs to be deposited is rupees 1 lakh. I hope the concept makes sense. So you deposit an amount today and continue reaping annual flows from that amount forever. That is what we mean by perpetuity. So 1 lakh rupee deposit today will give 10,000 forever every year. This is the concept of perpetuity. Only this needs to be covered here. Then next we come to some questions where you have missing values and you need to locate those missing values. So now in this question, a financial institution offered that it will pay a lump sum amount of 12,300 at the end of 8 years to investors who pay 1,000 annually for 8 years. Now, the future value that has been offered by the financial institution is rupees 12,300, and the time period is 8 years. So, this amount has been promised at the end of 8 years to people who will be paying annuity of 1,000 per annum. So, you need to see, or you need to calculate that what is the implicit rate of interest. Now, the future value will be present value, the annuity amount into the annuity factor. So, अभी तक हमने, this is what we have done, present value into 1 plus I raised to the power n. So we can directly see that this is a question of annuity. So we use the PVAF table for percentage we do not know. So I write here I% and 8 years. This is what my formula comes to be. जो मेरा एनुअल कैश फ्लो है वो 1,000 है into the annuity factor, because this is an annuity for 8 years. This will grow to rupees 12,300 in 8 years. So now I need to calculate the rate of interest that is offering this return. This will come to 12.3. So how to go about this? For this, I will need to go to the PVAF table. Till here, I hope it's clear to everyone. What I am stuck at is a value of 12.3, but I don't know how to calculate the rate of interest. So I go back to the PVAF table. So yes, this was the PVAF table. I have a value of 12.3. What I know is that 8 years is the time period of this investment. So now in this table, I don't know the rate of interest. What I know is 8 years. So I start moving horizontally, and good Spriha you have solved. I start moving horizontally and I look for the closest value to 12.3. So, so not able to get one here. I move to rate of interest after having the correct table. Okay, sorry. I am using the future value table. I wrote it incorrect there. So actually it is FVAF table. क्योंकि ये ग्रो कर रही है वैल्यू तो हम एक्चुअली कंपाउंडिंग कर रहे हैं. So I go to the future value annuity factor table. There I start moving horizontally at 8%. This is the table TVAF. I'm not sure I'm having it here, but you people can have a look. You will move horizontally and I'll show you from the book here then. You move horizontally and you land up at 12.3 or a value closer to 12.3 under 12% rate of interest. Yes, so this is the table I am talking about. You are having this handy with you. So corresponding to 8 under 10%, I am closer to 13.59 value. Then I move further to the next page of the table, and there against 8 years or 8 number of periods, 12.3. I'm getting the exact value 12.3 under 12%. So I am able to calculate the implicit rate of interest I as 12%. So when you have missing values, narrow down to the closest value that you can calculate. And next we take help of the relevant time value table. So here it was future value annuity factor, and depending on the case which we have, we will accordingly look for the missing value. So here the rate of interest was missing. I'll take up another question where the time period is missing, and using help from the table like we did right now, we will locate the number of periods. But before that, is this clear to everyone? Yes or no? I'll move to the next question. You can try attempting the question on your own. Again, this would also be a question on compounding. Find the number of years required to accumulate a sum of 2500. So now my future value is 2500. My initial cash flow or investment is 1000. So now this is a single cash flow, and the rate of interest given in the question is 10%. But what I don't know is the number of periods. So this is a case of annual compounding, so I don't know the number of years. Again, future value is equal to present value or cash flow. And now I am using FVIF table because of single cash flow. Put in all the values that you know, narrow down to a single value that we look for in the table. So the last value that we can calculate is 2.5. Now I will again go to the table and I don't know n, so I will move vertically in the FVIF table. I will move vertically from 10% and I will look for a time period that is closest to having a value of 2.5. So CVIF or CVF, FVF table 10% से आप vertically move करोगे, and when you move vertically, this is a single cash flow. So you need to find out the value that is closest to 2.5 and it is coming somewhere here next to 10 years. Yes, check in your tables whether you are getting this value. Yes, so 10 years approximately would be the number of years for which compounding is done. So this is how we find the missing values. This is another type of question on time value of money. Let's move further. Now, this is where we start with the application of time value of money. Now, we have done the concepts, how we calculate, how we compound and discount cash flows, how we locate missing values, and what is the effective rate of interest if there is multiple compounding. Now we come to the applications of time value of money in our real day-to-day life. So, one example we'll take up. A company wants to replace an existing machine after 5 years. The machine is likely to cost 5,20,000 at the end of 5 years. However, 20,000 can be realized by selling the existing machine at that time. Find out the annual amount that needs to be deposited at 10% rate of interest for the next 5 years to get the desired sum of money for replacement of the machine. Now, your company or your factory is having a machine that will be operational for 5 years. At the end of the fifth year, this machine needs to be replaced. Now, the cost of new machine will be 5,20,000, and what we get to know is that this old machine can be sold as scrap at the end of these 5 years. Scrap value of old machine is 20,000. So effectively, to purchase the new machine at the end of fifth year, the total sum required or funds required are rupees 5 lakh. Okay, this is the first piece of information given in the question. Second thing, N is 5 years, and you want to know the annual amount that needs to be deposited to raise this money. So this is a question on annuity. When we solve such questions, first thing that we find out is whether we need to calculate the present value or the future value. Next, whether it is a question of unequal cash flows or annuity. So in our case, what we know is that this is a question of annuity. We need to know the annual amount every year that needs to be deposited, that grows to 5 lakh rupees at the end of fifth year. So now this question can be solved in two ways, but I'll tell you the easier way. If anyone wants to know the other way, then I can explain that also. But to avoid confusion, I start with the easier way. Future value 5 lakh. So 5 lakh is equal to annual cash flow into FVAF 10% for 5 years. Your annual cash flow, your annuity compounded will grow to 5 lakh rupees at the end of fifth year. So you can now solve it easily. In this case, the FVAF comes to 6.105. 81,900 rupees if deposited annually for 5 years will grow to 5 lakh at the end of fifth year. So what I have done is I have taken all the cash flows to a future date using the CVAF table. Take a minute, look at the solution and see if there's any doubt, any question you can ask.